Okay, today we're going to learn how to prove a parallelogram in coordinate geometry. Please make sure that if you do not want to print out the notes, that you take out a piece of graph paper and some loose leaf paper so that you can follow along. The first thing that we need to go over is what is a proof. A proof is a way to show that a picture in the coordinate plane is what it is stated to be by using mathematical formulas. To do a proper proof, you need to know the properties of your shapes, whether the opposite sides are congruent, if the opposite sides are parallel, if the diagonals bisect each other, if all four sides are congruent, etc. You need to know what the formulas show. Distance shows if segments are the same length, which means they're congruent. Slope shows if two things are parallel or perpendicular. And midpoint shows if segments bisect each other. These are very important things to know. So to create a coordinate geometry proof, first, you're going to write in sentences what you plan to do. For example, you will write down, I will use 4 distance formulas to show the opposite sides are congruent. Second, you have to write out all the formulas to show your work. So in this case, you would do the 4 distance formulas of the 4 sides. Then third, you have to write in sentences what your work showed. So you're writing a mini paragraph. And it would be something like, since the length of AB is congruent to CD, and the length of BC is congruent to DA, the opposite sides are congruent, therefore quadrilateral ABCD is A. And you would say what it is. So the first thing that we need to know, because we're going to talk about a parallelogram, is what the properties are. First, your opposite sides are parallel, which means that this and this are parallel, and this are parallel. That's this one, parallel. Second, your opposite sides are congruent, which means this side is the same length as this side. This side here is the same length as this side here. Third, that's the sides. Third, opposite angles are congruent. So that means angle A is congruent to angle C, and angle D is congruent to angle B. The fourth thing is that consecutive, and if you forget, consecutive means next to, are supplementary. And again, that means 180 degrees. So for this one, angle A plus angle B equals 180. Or angle B plus angle C equals 180. Angle C plus angle D equals 180. And angle D plus angle A equals 180. The next thing is that the diagonals bisect each other. Remember, when we see the word bisect, I need you to think cut in half. And the sixth property we need to know is that the diagonals create 2 congruent triangles. So if we were to draw a diagonal in here, this we would say is triangle 1, and that's triangle 2. Those 2 are congruent. These properties are going to come up again for the rest of the year in geometry. Now, to actually do the proof, first thing we want to do is review the properties that we know. So the properties that we just went over: opposite sides are parallel, opposite sides are congruent, consecutive angles are supplementary, opposite angles are congruent, the diagonals bisect each other, and the diagonal creates 2 congruent triangles. Okay, that's not going to be asked in a proof, but we want to look at these properties because we're going to pick the one that we're going to prove to show that we have a parallelogram. So I'm going to go with this: the opposite sides are congruent. So the first thing when we're doing a proof, a coordinate geometry proof, we're going to graph the picture. So M is 1, 1. A is 3, negative 2. T is 4, 1. And H is 2, 4. So that's M, A, T, and H. Now to prove this is a parallelogram, first I'm going to write my plan. Since I'm going to show the opposite sides are congruent, my plan is I will use 4 distance formulas to show the opposite sides are congruent. Now we have to show that the 4 distance formulas prove that the opposite sides are congruent. So we're going to actually do 4 distance formulas. So I don't have a lot of room here, so I'm going to write the formula once. And then I'm going to actually do all the distances. I've got MA, AT, TH, and HM. Those are the 4 sides. So I'm going to hit pause on the video for a minute so I can do the distance formulas. You try them on your own. Hit pause. Okay, so now I did the 4 distance formulas, and if you notice, MA is radical 13, and TH is radical 13. That means, if I look at my graph, this side is equal to this side. I also noticed that AT is radical 10, and HM is radical 10. So AT and HM are the same length. That shows me the opposite sides are congruent. So now I proved that MATH is a parallelogram. So the only thing left is to write a conclusion. When we write our conclusion, it seems annoying and it seems obnoxious. You're explaining what your work shows. So all you have to do is write, since the length of MA and TH are both radical 13, they are congruent. Since the length of AT and HM are both radical 10, they are congruent. And then you're going to say a quadrilateral with both pairs of opposite sides congruent is a parallelogram. Therefore, MATH is a parallelogram. I know this seems ridiculously, like a ridiculous amount of work. It is a lot of work, but it is easy. All you're doing is mastering the distance formula for this proof. So again, when we do a proof, we're going to start with a plan. What are you going to do? Then you're going to show your work, so you're going to do what you say you're going to do. And then you're going to write a conclusion, and when you write the conclusion, you're going to pretend the person looking at all of your math does not understand what it shows, so you have to explain it to them. Again, I know it's a lot of writing. It is possible that this could be a 6-point question on your Regents exam. Please make sure that you email me with any questions or ask me in class.